So I saved some time here and just filled in this table for us, just simply going around doing sines and cosines of our 4 important values we've been looking at all year. So this is what you get. So you say, well, how do I graph a comma 0? You literally just pick a point and call that a. Just whatever distance it is, just make it consistent. So then 0a is up here, negative a 0 is back here, and finally 0, negative a is down there. So if you go the same distance in every direction, it's a circle, the center at 0, 0 with a radius of r. Your arrows are clearly going this way, because as we graph going down, that's the direction we have. But this asks us to convert the parametric equation into rectangular. So if you get a picture, you could look at this and say, well, my circle equation is just x squared plus y squared equals radius squared. You could just say this. Now, let's say it's more complicated, you're having trouble plugging the t's in, whatever. There's got to be a different way to do that. Here's what you would do. Last time we said to solve for the t, but you certainly don't want to be dealing with inverses for these. So what I would do is say cosine of t is the same thing as x over a. Sine of t is the same thing as y over a. Use the Pythagorean identity we haven't seen in a while and square both of these. So that comes out to this right here. Now, how'd they get the a squared on the other side? Simply just because the identity equals 1, so they just multiplied everything in here by an a squared. Cancel, cancel, that turns into a squared. There's the same thing we just had. So you get a couple choices with this when you see the sines and cosines. You can graph it yourself and try and create the equation, or do this substitution thing here with these using our most basic trig identity. Now this one's a little bit different. Okay, they're going to want us to do the exact same thing. So get a picture of this and get an equation. Here's your 2 parametric equations right here. We do have a domain in this case, unlike last time, and then lastly, it's telling us that the a's got to be positive. So make your chart. T says we're going from 0 to pi. Only thing we have in between that we definitely know is a pi over 2, unless you want to get into our special right triangle things. Okay, so x equals a negative a times the sine of 0. Sine of 0 is 0, so that has to go to 0. Y equals a negative a times cosine of 0. Cosine of 0 is 1, so this has to be negative a down here. We do the same thing again, plugging in a pi over 2. Fill in our table, so sine of pi over 2 is 1. So negative a cosine of pi over 2 is a 0. Sine of pi is nothing. Cosine of pi is negative 1. So this is negative a times negative 1 goes to positive a right here. So you graph this. 0, negative a. Negative a, whoops. 0, negative a would send us down here. Negative a 0 would send us over here. And 0a would send us up to there. So here's the curve. So it's a half circle. And it's coming this way like that with your arrows. So we've been able to get a picture. But what we haven't done is been able to get an equation. So if we do that same thing again, we can say sine of t is x over negative a, simply by solving this. We can say cosine of t is y over negative a, simply by solving this. We know the most basic trig identity is this. Do a substitution here, substitution here. When we square those negative a's, it's not going to change anything. And I'm just going to multiply across by the a right away. Okay, that defines a full circle. So you need to somehow say, you know, this is only good for, you could pick like this. Okay, so you could say, you know, only for y's that are from negative a up through positive a. So if you give that equation, it's going to give you the full circle. If you somehow designate we're only looking at half of that circle, you could do that. Okay. All right, last thing here, we're going to kind of fly through this a little bit quick, is projectile motion. So if you've taken physics, this will look familiar to you. So, you know, let's say you shoot something up into the air and it takes this path. Well, it's got two components to it, clearly an x and a y. We know anything on an x deals with a cosine. We know anything on a y deals with a sine. So we split it up into parametric equations. X of t, v sub 0 cosine theta times t. V sub 0 is that initial velocity that you shoot that thing off with. Now that's all that x controls, is a cosine coordinate. You come over here to the y, but if you think about what's happening in the y, you got to add in this gravity constant, you have to add in the sine component, and also the starting height. So if you had me for Algebra 2, we did some projectile motion problems where we looked at this y equals equation, and we did all kinds of quadratic stuff with it, and that's basically what we're going to do now. Okay, so you guys will have those equations, and you guys with physics are used to them. All right, let's look at one example here. So this Adam Johnson guy, you don't know who he is, and he's throwing a tennis ball instead of hitting it. But anyway, so he's got an initial speed of 40 meters per second at an angle of 45 degrees to the horizontal. So the ball leaves his hands at a height of 2 meters. So we want the parametric equations that describe the position of the ball as a function of time. So where is it on the x-axis at 4 seconds? Where is it at the y-axis at 4 seconds? So we literally just have to take our equations and plug some stuff in. We said the initial velocity was 40. This is cosine of 45 degrees times time. We said -1/2. Since we are in meters per second, we want to use that 9.8. That is gravity. Then you want to add in his initial height of 2 meters. So there's your equations. Now, like always, if you got a cosine 45, you got a sine of 45, you want to simplify these guys a little bit more. And this is what should happen. So go plug those in and then tell me this is the equation and this is the equation. Okay, 45s are nice, so are 30s and 60s. Okay, once you have the equation, we're going to do stuff with parabolas that you guys have done before, Algebra 2 and College Algebra. So we're going to take this quickly to part 3 and just show you how to get them set up because you guys can do the math.